Right, next we have to create the shared memory. SHM-get is used to do that. Every shared memory is identified by a unique integer ID. 1, 2, 3, 4 is the ID in our example. The second parameter of SHM-get is the size of shared memory required. And the third parameter are the permissions along with IPC_create flag. The return value of SHM-get is inspected for errors, and after that, before the shared memory can be used, the process must to the shared memory, and this is done using the call to SHM-AT. This has been covered in detail previously. The parameters of SHM-AT were also explained back then. What SHM-AT will return is a void pointer, and this void pointer is used to gain access to the. In our case, there is a structure inside the shared memory. So in order to access the fields of the structure, we need to have a pointer of a structure. So the next line will copy the address inside the void pointer variable into a variable which is a pointer to a structure. So there's a casting operation involved. Struct shared underscore use underscore st asterisk. This is the expression for casting. So shared stuff is now the variable which points to a structure. This structure is placed inside the shared memory. From this point onwards, we just need to use this pointer. Next we have the while loop, which is the main running loop inside the consumer process. And as you can see that the body of the while loop, first a call to semWait, then it is going to display the contents inside the sum_text field. Notice the line in the printf, shared underscore stuff, and then sum_text field. This is displayed, and after that there is this condition which is inspected. If the field sum_text contains the word end, this condition will be true and the variable running will be set to 0. This variable running is simply used to control the while loop. The very first line inside the body of the while loop is sem_wait, and the last line is sem_post. Notice that this is on two different semaphores, semIDF and semIDE. SemIDF, which refers to the fulls semaphore, was initialized to 0, and SemIDE, which refers to the empties semaphore, was initialized to 1. Once the consumer process is out of the while loop, next we have some cleanup operations. So the first thing we see is a call to SHMDT. This call will detach the process shared memory. All of this is done along with error checking. Then there is a call to SHMCTL, which is used to delete the shared memory. The use of SHMCTL was discussed when shared memory was explained. After that, we have two calls to semClose, one semaphore at a time. So over here we are closing the two semaphores. And after that, the consumer process is going to finally call semUnlink. And notice in semUnlink you have to specify the file name of the semaphore. SemUnlink must be called after semClose. So we close both semaphores in the consumer process, and then the consumer process also happens to